So let's look at another example of using binary variables in an integer program. This is the set covering problem. It's a variation of just the covering model in general, and the variation is, or the specialization, the narrowing of it is that all of the variables are binary. So we're going to have a BIP here, a binary integer program. The parameters and the constraints are all zeros and ones. So we're going to have a nice looking matrix that's all zeros and ones. In the classic version, each potential site is described by a subset of locations that it can cover. The problem then is to cover all the locations with the smallest number of new sites. Right? So let's look at the example. We have here a public emergency system. The city is divided into 9 different districts, 7 of which are potential sites for possibly locating emergency vehicles. The equipment aid site can reach some, but not all of the districts within the 3-minute time requirement. So we already know which districts could be reached from each possible site within that 3-minute threshold. An entry of 1 in the means that the district can be serviced from the corresponding site within the time requirement. If it's a 0, it means it cannot. So here's what the data looks like. So we have 7 potential sites, which I'm calling S1, 2, 3, all the way up to S7. We have 9 districts, D1 through D9. So for example, if site 1 is chosen, it cannot reach district 1. It can reach district 2, it can reach district 5, district 6, district 7, and district 9, all within the 3 minutes. Site 2, on the other hand, can reach district 1, 3, and 4, etc. Right? So to formulate this problem, we're going to say let y sub I equals 1 if the site I is chosen, 0 otherwise. The objective function then is to minimize the sum of the y's. So minimize the total number of sites that we pick. The constraints then will have 9 constraints, and they will look very much similar to this, which is district 1, district 2. So I want to make sure that I cover district 1, I cover district 2. So to cover district 1, there has to be at least one site chosen from sites 2, 4, and 7. We can see this right here in this first row. So to cover district 1, we either have to put something in the site 2, site 4, or site 7. Right? And we do the same for all 9 districts. So that should very much correspond to that big table back there. So let's go in and try to solve this guy using Excel. Where did I put it? There it is. All right, so this is my output. We have site 1, site 2. Is Excel smart enough to do this for me? Maybe, maybe not. 3, 4, 5, look at that, 6, 7. All right. The objective function, subject 2, cover district 1, cover district 2. Let's see if Excel is smart enough to go down 3, 4, 5, 6, 7, 8, 9. Yay. It makes my life a little bit easier. Let's make those a little bit smaller, and then go ahead and center all this. And these are my outputs, so I'll make them my pretty blue color I like. The objective function, we're going to be 1s in each of these, right? And then we'll have our left-hand side and our right-hand side. And to cover district 1, it would be site 2. So all I'm doing is I'm looking on my other screen on my computer what the constraints are from slide 40 on the thing. So, and I'm just going to leave blank the ones that it doesn't work for, right? And all of these are going to be greater than or equal to 1. I hate it when it does that. I like it sometimes, and then sometimes I don't like how it does it. All right. District 2, Site 1, 6, and 7. Then District 3, we have Site 2 covers it, Site 6, and Site 7. District 4 is 2, 3, 5, and 6. District 5, 1, 3, and 5. District 6 is 1, 4, and 6. District 7, 1 and 7. District 8, 3, 4, 5. And then, let's see, let me get rid of, I had some of this stuff up here, let me get rid of that. District 9 finally is 1 and 5. 1 and 5, right? All right, so I think that is correct. So now let's go into Solver. I'm going to set the objective of K2. I'm going to minimize by changing these guys, those variables, S1 through S7. Subject to the constraints, they're all greater than or equal to constraints, so I can add them all at the same time. Make sure I switch it to greater than or equal to. There, click OK. And I'm going to try solving it without integers first and see what happens. So I click Solve. And notice that we get an answer, which is good, but it's not a whole number. It's 2 1/3. So I get a third at site 1, a third here, 2/3, a third, 2/3. All right, so that doesn't help me. I can only put a site. I can't do a third of a site. I have to do the whole thing. What this does do, however, is that it gives me a lower bound. The best I can do with the relaxed solution without imposing binary variables is 2 1/3. So if I impose binary variables, all of them have to be zeros or ones. What's the best that I can do? Well, it would be 3. So I hope to get an answer of 3 when I put binary restrictions on the variables. So let's try it. I'm going to go ahead and empty these guys out. Click Solver again. Now I'm going to add the binary. So remember to do this. Point the left-hand side to the variables themselves. Click BIN for binary. Click OK. Now I have the binary. I have this. Go into Options. Go ahead and make sure that the integer optimality gap percentage is down to 0%. Should be OK for all the small stuff we do in class. Click OK. Solve. And we see, yay, we should put sites at sites 4, 5, and 7. That's the minimum, 3. And then we see that District 1 is covered by more than one site, as is District 8. So if you cared about response times, emergency vehicles getting to your location, then you might want to live in District 1 or District 8. So this solution, this problem actually has multiple optimal solutions. The reason being is that the objective function is very, very broad. All it says is minimize the total number of sites that we put there. We could certainly try to change the objective function to something else. We could try to change it to cost if we had a way to add cost to it. We could try to talk about how to make sure that we have lots of places, lots of districts that are covered by more than one while still minimizing. But I'll let you go ahead and figure out how to come up with a different optimal solution that is still 3 sites but still covers everything.